Okay, so here we're doing the practice test for acids and bases. Excuse me. Number 1, circle all of the following which can act as acids. Remember, the definition of an acid is oopsies, let's get rid of that. The definition of an acid is a compound that can donate an H+. So you're looking for things that start with H's. So here's one and here's one. And so these would be our two acids. Carbonic acid here and sulfuric acid there. Number 2, circle all the following which can act as bases. Remember, the definition of a base is a compound that can donate an OH-, a hydroxide ion. So you got to look for anything that has an OH at the end. So that's that one, and that is it. So this is our only base. It's aluminum hydroxide. Number 3, complete and balance the following acid-base reactions. Okay. So here we have hydrochloric acid plus calcium hydroxide. So remember that they will always form a water. And the salt is these two things. Because remember, the water is formed from this and this coming together. That's what forms the water. So the Cl- and the Ca2+, that's what's going to form the salt. And so where do I get the 2+ and the minus from? I'm looking at the periodic table if you don't have it memorized. I mean, if you don't have these charges memorized, and that most people don't. But the calcium's in group 2, so it's a 2+. The chlorine's in group 7, so it's a 1-. So you got to balance out the charges, so it's going to be CaCl2. Remember that the metal always comes first, and the non-metal always comes second. Now all we got to do is balance this thing out. So we're going to balance this thing. We got 1 chlorine here. We got 2 over here. So let's put a 2 here to start by balancing that. So we're good on chlorines. We got 1 calcium here. We got 1 calcium here. So we're good on that. We got 2 hydrogens here. We got 2 hydrogens here. So we only got 2 over here. So we're going to put a 2 right here. And that will be, that will even out the hydrogens. And we got 2 oxygens and 2 oxygens. So this is the correct balancing. We have a 2 in front of the HCl, and we got a 2 in front of the H2O. The next one is H3PO4 plus NaOH. So we got to figure out what this makes. This makes, of course, water. And the PO4 and the Na will come together. The PO4 has a -3 charge. The Na has a +1 charge. So you're going to need 3 NAs to balance out the PO4. So that's sodium phosphate. And let me just double check that. Yeah, that was right. All right, so now we just got to balance this thing. So
Steve, I'm done with my piles, so you got to pick up your own piles.
So we're going to balance this thing out. We got 1 sodium here. We got 3 over here. So let's put a 3 right there. That balances out the sodium. We got a single phosphate ion here, a single phosphate ion here. So that's already balanced. We got 3 hydrogens plus another 3 hydrogens, which means you got 6. So you better put a 3 right here to balance that out. And that is now correct. That is completely balanced out. You got a 3 in front of the NaOH, and you got a 3 in front of the H2O. Now let's do the last one here. Aluminum hydroxide and sulfuric acid. Of course, it makes water. And now we got an aluminum joining up with the sulfate. So aluminum has a +3 charge. The sulfate has a -2 charge. Again, you can figure that out from the periodic table, or you can figure it out from your list of polyatomic ions. That's sulfate. So you got to balance those out. That means it's going to be Al2SO4 because the lowest common denominator of the charge is 6. So now we just got to balance this thing out. So let's put, we got 2 aluminums here, but only 1 right here. So let's put a 2 right there. Let's see if that helps us out. We only got 1 sulfate here, but we got 3 over there. So let's put a 3 right there, see what happens. So we're good on the aluminums. We're good on the sulfates. Let's count up hydrogens. So we got 6 hydrogens over here, right? You got 3 times 2. 6 over here and another 6 over here, which means you got 12. So you got to put a 6 right there to get that to balance out. And that is now completely balanced. So this is our formula, completely balanced for the neutralization of the acid and base. So let's just do the last couple questions here. What is an acid? An acid is defined by the fact that it's able to donate H+, so it is a compound that can donate an H+ ion. What is a base? It is a compound that can donate a hydroxide ion, which is an OH- ion. So that's what defines those. That looks like I got some more time before this video gets too long, so I'll continue. Number 6. Two acids are sitting in beakers and their identities are unknown. Beaker 1's acid reacts slowly with metals. So remember that there's 3 ways you can determine the acidity of an acid. One is how well it conducts electricity. 2 is how quickly it reacts. And 3 is use a pH meter, right, a pH probe. So, yeah. So if it reacts slowly with metals, that means that this must be a weak acid. Beaker 2's acid conduct electricity poorly. Remember that strong acids conduct electricity really, really well because there's so many ions, negative ions going around, and that's what conducts electricity. So if this conducts electricity poorly, that means that it is also a weak acid. Sketch the particles in a strong acid. Okay. So here's our beaker, a side view. A strong acid means that the HCl's, almost all of them, almost 100% dissociate into H pluses and Cl minuses. So I'm going to put a bunch of H pluses in here, like this. And I'm going to put a bunch of Cl minuses in here too. Okay. I'm going to put one HCl in here just to show that the dissociation wasn't 100%, that there was one left over. But remember that strong acids have dissociations that are almost complete. So I just put the one in there to show that, it wasn't 100% complete. If it was a weak acid, you would have a bunch of HCl's and not very many H pluses and Cl minuses. That's what it would look like if it was a weak acid. Okay, let's move on to number 8. This is a indicator lab table, and very similar to what we did in class. 4 indicators, A, B, C, and D, and it tells you what color they turn depending on the pH level. So A, if solution has a pH of 7, what color will you see if you add indicator C? pH 7, is that less than 4 or greater than 4? It is definitely greater than 4, so it's going to be red. A solution is blue when mixed with indicator D, but orange when mixed with indicator B. Determine the pH range. Okay, so let's start with B. If it turns orange, that means that the pH is less than 2. So I'm just going to write that down here for a second. So if it turns orange, the pH is less than 2. And for D, it will only turn blue if the pH is greater than 1. So if it's greater than 1 and less than 2, that tells you that the pH range is between 1 and 2. Right? It's got to be greater than 1, less than 2, so it's got to be in between those two. If a solution is purple when mixed with indicator A, what number is its pH likely? So notice that there's only red and blue. There's no purple. But if you were to look at, well, let's think of it this way. If it's red and blue together basically is purple, right? So purple is sort of a mix between these two. So if you think about it, purple would, if you think of this as a sort of a spectrum, right? Purple would be right in the middle between red and blue. And so the pH must be right around 6 because it's really a blend of those two reds and blues. So it's got to be right around 6. So around 6. D, a student accidentally adds indicator A and indicator C to the same solution. The color of the two indicators is purple. What's the minimum possible pH? So we're talking about A and C right now. So I'll do some blue. So we're talking about A and C, and it turns purple. So let me just erase some of this. Okay. So this is red, this is blue. So A can turn red or blue, and C can turn green or red. So what combination would be purple? Well, purple's red and blue, right? So it can't be green, so we got to get the red from here, which means we have to get the blue from here. In order for C to be red, the pH has to be greater than 4, okay? In order for A to turn blue, the pH has to be greater than 6. And remember that both are happening in this solution, right? Because you've accidentally added A and C together, and somehow you're getting purple. So what we need to find is something where both of these things are true. So the lowest possible number that this could be is 6, right? So I'm going to write that down here. What's the minimum possible pH? 6. And again, you're going to say, well, why isn't it 4, right? Because 4 is a lesser number. Well, if the pH was 4, then this 4, it would be red right here, right? Because pH less than 6 is red. So this would only be red. This right here, it will only indicator A will only turn blue if the pH is 6 or higher, and it has to turn blue for this whole thing to turn purple. So the lowest pH of this substance could only be 6, because if it's 6 or higher, then this will turn red and A will turn blue, and that's how we get the purple. And then E, of course, is the same thing as B. The pH is between 1 and 2. It's the same question. All right. Describe what the process of titrations is used for. It uses a known solution to neutralize an unknown solution and uses an indicator to show when the pH is 7. Now that's not great writing. You know, I'm about to say I'm not an English major. I am actually. I have an English degree, but I'm just doing this off the top of my head. It's when you use a known solution to neutralize an unknown solution, but you have to use an indicator to show when you have successfully neutralized it and turned the pH to 7, right? That's when the indicator changes color. All right. It takes 20 milliliters of acid A to titrate a certain base. It takes 80 of acid B to titrate the same base. Which acid is stronger? Okay. So notice that it takes way less acid A to titrate that base, which means that acid must be way stronger, right? Because it doesn't take very much. It doesn't take very much acid A to completely neutralize it. And then if you're using the same base, it takes a ton of acid B, which means that acid B is probably pretty weak. How many times stronger is it? Well, 80 over 20 is 4. It's 4 times stronger, right? If it takes 1/4 the amount, right, it's 4 times stronger. All right, so that's how you want to think about those. Similar question on 11. 25 milliliters of some base, some sodium hydroxide, is neutralized by 35 milliliters of acid A. And if acid B is 5 times stronger than acid A. Okay, so if acid B is 5 times stronger, it's going to take 1/5 the amount. So what's 1/5 of 35? It's 7. So if it's 5 times stronger, it will take 1/5 the amount. 1/5 of 35 milliliters is 7, so it'll only take 7 milliliters. This 25 right here is not important for this question. It's just telling you how much base is being neutralized. What's really important is the amount of acid. Okay? What color does phenolphthalein turn? Pink. I really should have written it like this. And why is an acid indicator added to the solution of a titration? So you know when the acid/base is completely neutralized, which is the same thing as titrated. And that is how we do the practice test.